Hello everyone, and welcome to my science fair presentation. Today I will be telling you a bit about my idea for this invention, the slip-safe mobility cane. It's very common for people to get injured during the winter due to ice and snow. The ice and snow sometimes causes car crashes, falls, cuts, and even death. Imagine how much harder it is for visually impaired people to avoid the ice that plagues our sidewalks and roads. For them, the winter season brings another obstacle to fear and something to make their life harder. The purpose of the slip-safe mobility cane is to detect ice on sidewalks and roads and deliver an audible and tactile notification when this ice is reached. It could save many from severe injury and help improve the quality of life of millions. I hypothesized that if an ice detecting walking stick is successfully built with audible and tactile notifications, then the user would be able to successfully avoid this ice and therefore injury. This product would work using infrared radiometry to detect the moisture and temperature of the ice. An infrared radiometer is a device that determines surface temperature and sometimes surface moisture without actually touching the surface. Wired to this radiometer would be a circuit board programmed to send a signal when the specific conditions of ice are reached. Then the wires would continue to travel up the cane, as you can see here, and would connect to several miniature buzzers and beepers underneath the handle. When these are triggered, it would deliver a notification that can be both heard and felt, or audible and tactile. Then the user can successfully move out of the way or proceed with caution. The slip-safe mobility cane model was built using a collapsible cane, a laser pointer, and other supplies. I assembled it using a hot glue gun and some tape. First, I drilled a hole into the tip of the cane and then fitted the laser to the hole. I hot glued it in and tied the internal elastic band to the opposite end of the laser. I then taped the button for the laser down and screwed it back in. This model was non-functioning, as you can probably tell, but the real product would be much more complex, requiring both a professional coder to design the circuits and a technician to help attach the radiometer. As I was planning my project, there were some things I observed. The first thing I observed is that the code for infrared thermometers, buzzers, beepers, moisture readers already exists, which is great because they are all key components in the slip-safe mobility cane. Yet, for some reason, the code for infrared radiometers that detect ice has never before been designed. Therefore, my code would have to be completely original. This would require a professional coder or somebody else to learn a complete coding language and then know what parts to put where in order to design my cane. Therefore, I think that this would need to be written by a specialist. So, therefore, it would not be possible for me to make a functioning model, as I would need, as I said, a professional coder and a technician, but also an infrared radiometer, which is a piece of equipment that's kind of hard to find and costs around $300. The other thing I observed is that mobility canes generally fold up when they're not in use. Yet, if I were to include a circuit board, I would need a circuit box in order to hold all the different components. If there was a circuit box attached to the side of this cane, as you can kind of picture, it wouldn't fold up properly, so this would present a challenge. There was no testing needed for my model, as it was not designed to function. Instead, I observed the answers of a survey I conducted on 28 friends, family members, and staff members at my school. As you can see from the graphs here, I don't know if you can see that, about a third of the surveyed population is or knows someone that is visually impaired. This came as a big surprise to me, as only about 4% of Canadians suffer from visual impairment. In the next graph, you can see that not many of them use mobility canes. This wasn't a huge surprise, as there are several levels of visual impairment and not all of them require a mobility cane, such as this one, in order to move around in their day-to-day life. The next question, you can see I asked them if they agreed that this was a good idea, and almost everyone agreed that my product would be really beneficial when working. There were a couple people who said they were neutral on the subject, and I blame this on a bit of a lack of an explanation. This led me to change my explanation to what you just heard. The last question I asked was about any questions or concerns that the surveyed population might have. This brought up some important topics and sparked the ideas for different advancements in my cane, such as adding textured rubber around the charging outlet so that it can be found through touch. I really enjoyed building this product, as there was different things I learned about. I learned about circuitry and about the different technology that is used in different smart canes and smart technology and technological devices. I also learned about the history of mobility canes and a bit more about how they work. This product would help visually impaired people live their lives with a lot more ease. The technology itself could be applied to many other things, such as walkers, balance canes, and even wheelchairs, with little to no modification needed. Companies such as Canes Canada, Lowe's, CNIB, and others would take an interest in my product, hopefully, and sell it and distribute it around the world. This cane would be ideally sold for around $400, as the main technological component costs about $300, and canes without any technological advancement cost $75 to $100. This price would allow me to still make a profit while being affordable and reasonable. And also the materials would be very durable and it would last the user a very long time. With the right resources and skill set, I am certain that the SlipSafe mobility cane will be a big success and that it will be very well received by the visually impaired community. Thank you!